Cristalinity. In general, it refers to how the molecules are organized. The more crystalline, the more ordered the molecules are. The term amorphous means no arrangement or order of the molecules. It's the opposite of crystallinity. The term degree of crystallinity can only be applied to polymers because they are macromolecules, and thus they can exhibit more and less crystalline zones. Let's see the example of the image below. Let's suppose that it represents a polymer, a macromolecule of a polymer. In the same molecule, we can have a crystalline phase or amorphous phase. The same material can have parts that the molecules are more organized, or parts that the molecules are not so organized. It's important to take in mind the crystalline properties of a material because it can change its property significantly. Let's take, for example, the polyethylene. Polyethylene, it's possible to have the high density polyethylene, which is a more crystalline type of polyethylene. And it's possible to have a low density polyethylene, which is not so crystalline like the high density. It has more amorphous phase. The properties are totally different, and also the end use application. For example, if you need an application that requires a higher modulus resistance, then a high density polyethylene, higher crystallinity, might be a better option. Meanwhile, if we need to produce, for example, a thermoformed flexible packaging where we need more stretchability, maybe a low density or even a linear low might be more interesting because you have more amorphous phase. And if you have a more amorphous phase, it means that you can stretch more the material.